Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to neural networks and we were discussing about the basic concepts related to learning and about the learning rules. There are five learning rules, main learning rules that are used for the training process of neural networks. We have discussed about error correction learning in the previous video. So in this video we'll be discussing about memory based learning. So we all know that the general objective of a neural network, it essentially is to go through the training phase, the learning phase, where it is subjected to new data, new kind of situations, new environment, new stimulus, and during that whole period, the training period, the learning phase, it undergoes changes in its internal structure in the form of change in weights, updation in the weights, or in the overall structure, by which it adjusts, it adapt itself to the changing environment, the changing situation, the changing stimulus, and the whole process, it generally involves generalization of the whole experience, categorization, forming clusters of the stimulus, the data which it gets exposed to, and then all those results that have been accumulated, the experiences that uh, is accumulated, it is applied to solve real life situations, real life situational problems. Okay, so that is basically the whole learning mechanism. Exposed to new environment, adapting, adjusting, learning from mistakes, uh, gaining experience, then applying that knowledge to solve new problems. Okay, so learning rules, we have discussed about error correction learning. The memory based learning is basically the way we human beings we memorize information, the basic way in which we handle our day-to-day life. It is essentially that memory based learning. So if you try to remember uh, in school how we used to prepare for an exam, okay, we used to memorize things, we used to give uh, mock tests before the final exam to prepare ourselves for that kind of a situation, simulating that kind of a situation. So like that, in memory based learning, the human mind, like it got exposed to new data, new situation, new stimulus, the artificial neural network is also exposed to new data, new situation continuously during the training phase. And the the data, the situations, the stimulus, the experiences, the concepts that it is exposed to, they are classified, categorized into different groups, forming patterns out of it, and it is generally based on their similarity with one another. Okay, so generally in memory based learning, it generally involves storing the training data or items, forming patterns out of it, categorizing them into different groups, and when new stimulus is provided, trying to correlate the past experience with the new situation so that it can handle it in a better way. So suppose I try to tell you, or I ask you, uh, give me the five most happiest experiences of your life, the happiest moments of your life. So here, when we hear the word happy, that is the main trigger, the keyword happy. So in our mind, we have associated the word happy with everything positive, everything good. So all the good positive experiences that we have had in our life, we store it in a in a particular uh, chamber in our mind, and that chamber is named as happy. You can imagine it like that. So it can be the first time you got A plus grades in all the subjects, or your team won the cricket match or the football match, or you went to the favorite restaurant to have a great lunch or dinner with your family, or to a favorite vacation spot during the holidays. It can be anything. So all those experiences you have stored, all those happy moments, good moments, you have stored in that chamber, and that chamber is called as happy in your mind. Similarly, if I say, what moments in your life made you sad? So, everything negative, bad, uh, not worth remembering, you have stored in a separate chamber in your mind, and you have called that, or you have named it as bad. It can be the first time you failed in a particular subject, or you got scolded by your teacher during in school, without it was not your fault, you thought it was not your fault, but still you got scolded, um, or you got scolded by your parents, or you lost a particular match. So like that, all those moments which are bad according to you, and everything negative you have kept in that sad chamber. So like that, whenever you got exposed to new data, you categorized it into different chambers in your mind, and you have assigned specific names to that chamber: good experiences, bad experiences, happy moments, sad moments. Or when it comes to your academics, you have categorized it as easy subjects, difficult subjects. Suppose you like, you enjoy, uh, uh, let's say, literature subjects. You like literature subjects, but you don't enjoy maths that well, you find maths difficult. So you have associated it with the word difficult, and easy you have associated with all the other subjects that you like. So like that, we generally form patterns in our mind, we form clusters of all the data that we have accumulated, we categorize them, we classify them into different groups, and each group we associated with a particular word. So that is what memory based learning is all about. And generally, when it comes to neural networks, it is based on different kind of principles, such as nearest neighbor rule. That is the main thing which we are going to discuss this whole video on. It is based on the nearest neighbor rule, although space decomposition and clustering methods, like I said, they are also used. So if we want to apply the nearest neighbor rule, if we want to understand it, then we can use a particular example. Suppose you are given with this information where there are some red blocks here, and there are some blue blocks here. And you can see there are two blocks A and B which do not have any particular color. They are colored with black. And you are asked to guess the colors of blocks A and B. Now, majority of the people who will be asked this question, they will guess that the color of A is red and the color of B is blue. Why? Because in their mind, they think that as A is in close proximity, it is closer to all those blocks that are red, it is part of that red group. And B, as it is closer to all the blue blocks, it is surrounded by all the blue blocks, it is closer to them, so it is part of that blue group. So the color of A will be red and the color of B will be blue. So this is what is called as the nearest neighbor rule, which is used in memory based learning. It is based on intuition. Okay, so the main important thing is that uh, we assume that it is part of this red group because it is closer to it, it is surrounded by that. And B is part of the blue group because it is surrounded by that, it is closer to that. So the nearest neighbor rule is based on the concept of distance between nearest data types, which is based on the Euclidean distance, the minimum distance between 2 points. And here the data which is exposed to the neural network, it is generally of two types. First is, it is called as, before a certain situation, any given situation at any given point of time, all the data which the neural network had already been subjected to, it has faced beforehand, that is called as the prior data or the training data. And all the data which it is facing right now and afterwards, it is called as the testing data. All the data experiences that it had already experienced, it has in its mind, that is called as the training data. And afterwards, which it will experience in the future, that is the testing data. So you can say that all the events in your life in the past, it is training data for you, it is the training phase. And the future and the present, right now and the future, all the new experiences that you are going to have, that is a testing data. Like that we can correlate all the past experiences, training, all the future situations that we are going to face is the testing data. So here the neural network, when it is supplied with a input vector, the training pattern, with, let's say, the components x1, x2, and suppose there are n components in that vector. Each of those components has a particular desired output, okay, target point, okay, like feedback, the output which it wants, and each component has a particular desired output, okay. So this whole thing is stored in a large memory. I'm talking about artificial neural networks, where each component of the vector has a particular desired value associated with it. So it is stored in the form of a classified input output example set, okay. For each component of the input vector, a certain desired value of the output is there, okay. Now for each thing, x1, the desired output is d1, for x2 the desired value is d2, for x3 the desired value is d3. Now a test vector, when a new situation the neural network is exposed to, a certain new signal is applied to it, then the next step is determining the local neighborhood or all the past experiences, the correctly classified input output examples which it already has in store, and seeing whether it is related, the new data, the test data is related to any of this input, the experiences, the training data set is related or it is similar to any of the previously stored data. So this is called as the local neighborhood, trying to find similarity between the new data and old data, that is comparing the test data with the training data. So this is applied to any new unknown vector, new signal that is applied to it. So depending on that, the similarity, how the similarity between the new data and the old data is determined by the artificial neural network, it is with the help of finding out the Euclidean distance between 2 points, okay. If 2 points, they are close to each other, to find out the distance we calculate the Euclidean distance in mathematics through this methods. Similarly, in neural networks, the Euclidean distance between 2 points is calculated, and here the 2 points are the new data which is given to it and the old data, training data and test data. So in any general input signal vector, let's say xn, it is said to be the nearest neighbor, that is close to the testing data, if the minimum distance between that vector and the test data is the Euclidean distance. Euclidean distance between 2 points in one dimension is the modulus of the difference between the distance between that 2 points, b minus a. And in case of two dimensions, it is just like that, with coordinates x1 y1, coordinates x2 y2 for a and b. It is calculated as per this relationship. So if the minimum distance between those 2 points is equal to the Euclidean distance, then it is said to be the nearest neighbor. And depending on uh, that kind of a similarity between data, the neural network responds in the same way. So uh, you can correlate it with a situation like, suppose you have to give a final exam. The more you prepare for uh, that kind of a situation, you give a lot of mock tests, before the final exam happens. You acquaint yourselves with that situation, you put yourselves through the same process, you go through the same situation. So the more you practice, the more you acquaint yourselves with that kind of a situation, the better you will perform. So it is generally, it involves training your mind to respond in a particular way when you are faced with that situation. So the more you practice, the more you expose yourselves to a similar kind of situation, the better you will perform when the actual thing happens. So like that here. So the experiences that the neural network it accumulates depending on the training data, the data which it already has, which is depending on the data which it is exposed to, depending on that, when a new data is given to it, it tries to find similarity between that data and the old data, the new data and the old data. And if it finds any similar experience to that, it finds out how it responded in that situation in the past. Okay, suppose it finds out that under such situation I responded in this way, so it tries to respond in that way this time also, and sees whether the output which it produces, it uh, it matches the desired output or not. Okay, so like that it happens with every other data. It is a very long and complex process, and then finally it just the new experience, they get added up, they're stored in the memory, and this process goes on. So it is very much similar to the way we prepare for a test, we prepare for a job interview. We uh, we we accumulate all the experience that we have of the previous interviews. Suppose we made a mistake in a previous interview where we are asked a particular question, and the interviewer, he or she did not like the answer. Okay, the way we responded to a particular question, he or she did not like and rejected you for that. The next time you go for a new interview, when you are asked the same question, you recollect that the previous time I answered it in this way, the interviewer rejected me. So you prepare yourselves for that. Okay, so if the next time you're asked with the same question, you will come up with a new answer, an improved answer, a better answer. So that is the whole point of this memory based learning is exposing the neural network to data. It stores the past data, the past experiences as the training data, and when new data, which is called as test data, is given to it, it tries to find similarities between the two data depending on the local neighborhood and the concept of nearest neighbor rule and the Euclidean distance. And if two data types are similar, that is the test data is similar to the training data, then it responds in the same way it responded in the past, and sees whether the output which it produces, it is close to the desired output or not. And this process goes on. So there are some certain aspects of memory based learning, that is what criteria is used for determining the local neighborhood. Here we are using the concept of Euclidean distance, and certain programming concepts are applied, the way we use the threshold values for a particular local neighborhood and all that, and how the Euclidean distance is calculated, and what conditions are imposed on that. And also certain conditions that are important in memory based learning is that all the classified input output examples, that is the desired values for a particular input, they should be independently and identically distributed, and the sample size should be large. It means a large amount of training data and test data. It should The neural network should go through, it should go through a rigorous process where it has a large amount of experience by getting itself exposed to new data. So it is just like the more you practice, the more better you perform in a particular situation. Practice makes a man perfect, like that kind of a situation. Okay, so this is all about the memory based learning based on the nearest neighbor rule, the determination of local neighborhood as per the Euclidean distance concept. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.